All right, here we go. Question 25 from our Calculus 1, homework number 4 in WebAssign. Similar to number 24, here we're given the function f of x equals 8x plus e to the 9x, and we want to use the formula, the derivative of the inverse of f of x equals 1 over the composition of f prime of f inverse of x, to find the derivative of the inverse evaluated at 1. Now, the first thing I want to point out in our scratch work is that our x is 1. So we're going to replace each one of these x's with 1 and go from there. And once we have that expression written down, we're going to focus on the inside piece, f inverse of 1. We need to figure out what is that. And so we know that f of x is y, meaning that in this notation, if you're given an x, you get a y. Switching that, f inverse would be of y equals an x. And so what we know is, we know in this case that the number 1 corresponds to a y in our original function. So we're going to need to set this function equal to 1 and solve for x. So that's going to give us 1 equals 8x plus e to the 9x. And I need to solve for x. Now, solving this equation for x may be tough and may require technology. But here's what my instinct tells me to do. It's to move the 8x over so that we can isolate the exponential piece. And that would give us e to the 9x equals 1 minus 8x. And then if we convert to a logarithm, that would be the natural log of 1 minus 8x equals 9x. And then again, notice that this has x on both sides, and the x is within the natural log. This is probably not going to be something that we can solve manually. We're probably going to need to look at solving this electronically. So if we go to Desmos and graph the left-hand side as one equation and the right-hand side as another equation, where the two graphs intersect would be the solution of our equation. And we can see that these two graphs are going to intersect at the origin, giving us a value of x to be 0. And then if we plug that back in, we can see the natural log of 1 minus 8 times 0 equals 9 times 0 would give us the natural log of 1, which is 0. So x is 0 is a solution. And again, what does that tell us? That tells us the value of f inverse of 1. So once again, trying to make this make sense, if I calculate f of 0 and replace every x with 0, what that's going to give me is 0 plus e to the 0. Remember, anything to the 0 power, as long as it's not 0, is going to be 1. So this would be 0 plus 1, which is 1. And so the inverse would say f inverse of 1 would produce 0. And so now I know that the inverse of 1 is 0, and I can substitute into this formula. That's going to be 1 over the derivative of the function evaluated at 0. And now to finish this out, I am going to need to find the derivative of my original function. And here we go. The derivative of 8x is 8. The derivative of e to the 9x, remember we have to take the derivative of the exponent first, and then it's just going to be e to the 9x again. So there's our derivative. We need to evaluate that at 0, which would be 8 plus 9, e to the 0 times 9, which is 0, is going to give me 9 times 1, which is 9. 8 plus 9 is 17. And so our final answer would be 1/17. And now all we have left to do is take our answer into WebAssign and see if we're right. And we got the green check of success. So that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.